So what is the example of reaction that undergoes zero order? The example of reaction is decomposition of ammonia. Decomposition of ammonia, it follows zero order. So we can write the rate law for this decomposition. We can write as rate is equals to K concentration of ammonia to the power of 0. Remember, rate law only involves the reactant only. Or we can just write rate is equals to K. Usually we will just write rate is equals to K for zero order. And the unit of the K is molar per time. How to determine the unit of K? It is very easy because we know that the rate law is rate is equals to K concentration of ammonia to the power of 0, or we can just write rate is equals to K. Rate is molar per time. Rate is always molar per time is equals to K. So that's why the unit of K is molar per time. And what happened to the rate if concentration of ammonia is doubled? We know that for zero order, rate is equals to K. Let's say we have rate 1. Rate 1 is K. Concentration of ammonia, let's say concentration of ammonia is 1 molar. Let's say, saja letak suka hati. Let's say you want to write as 10 molar, suka hati. 5 molar, suka hati. Rate 1 is equals to K, 1 molar to the power of 0. So, rate 1 is equals to K because any number to the power of 0 is equals to 1. And what happens if concentration of ammonia is doubled? If concentration of ammonia is doubled, so we write rate 2 is K. Maybe here at this rate you can write K concentration of ammonia to the power of 0. Okay, rate 2 is equals to K. Now the concentration of ammonia is 2 molar. Why 2 molar? Because concentration is doubled. Okay, so you write 2 molar to the power of 0. So what is the value of rate 2? Rate 2 is also equals to K because 2 molar to the power of 0 is equals to 1. So what happened to the rate when concentration of ammonia is double? We can see that rate 1 is equals to rate 2, or we can say that rate is remain unchanged. So that is the answer. So if zero order, what happened to the rate if concentration of ammonia is reduced by half? So once again we write the rate law. Rate is equals to K concentration of ammonia to the power of 0. So rate 1 is equals to K. Let's say the concentration of ammonia is 1 molar to the power of 0. So rate 1 is equals to K. What happened if concentration of ammonia is reduced by half? So rate 2, the new rate is equals to K. Reduced by half, 1 molar, so it becomes 0.5 molar to the power of 0. Meaning that rate 2 is also equals to K. So the answer is rate remain unchanged. Okay, meaning that now, even though we change the concentration of ammonia we double the concentration of ammonia, or we reduce the concentration of ammonia by half, whatever we do to the concentration of the reactant, what happened to the rate? The rate is always remain unchanged. So when we plot a graph, or we want to sketch the graph of rate versus concentration, rate versus concentration of the reactant. Now the reactant is ammonia. So what happened? Kita tukarlah macam mana pun concentration of the reactant. What happened to the rate? The rate is always constant. So the sketch of graph rate versus concentration of the reactant is just a constant graph like this. So this is what happen if the reaction undergoes zero order.